Hi class, my name is Ashley and I'm doing my final teaching video on nephron action. So now that we all know that the nephron is the main functional unit of the kidney, which I did not know before, so hopefully I wasn't alone in that. There are over 1 million nephrons in each of our kidneys. So let's talk about the anatomy of a nephron first. We can understand its function. So here's a page I drew of the nephron. So here's the afferent arteriole, which goes to the Bowman's capsule or glomerulus capsule, where the glomerulus is inside. The efferent arteriole, the proximal convoluted tubule, the loop of Henle or nephron loop, the distal convoluted tubule, collecting duct, and then we have all of these capillaries up here and down here in the vasa recta capillaries. And then it's important to note that this part, the upper part of the nephron, is in the outer cortex of the kidney, and this part down here, like the loop of Henle and the collecting duct, are in the medulla of the kidney. So the nephron can really be boiled down to having three functions, and it's filtration, reabsorption, and secretion. So blood is brought to the kidneys via the renal artery, and it goes to smaller vessels till it gets to the afferent arteriole. And that's where our blood plasma comes in, goes into the Bowman's capsule or the glomerulus. And this is important because this is where filtration takes place. In fact, it's going to be filtered 3 times inside here, 3 different ways. And everything that we want to keep is going to go here into the PCT, and then what we get rid of is going to go out here, the efferent arteriole. And this works because the afferent arteriole is larger than the efferent, so it creates arterial pressure that is the driving force of filtration through the glomerulus. So what kinds of things do we send out? We send out waste products, so we send out hydrogen ions and ammonium ions, things like that. But this is called filtrate at this point. This is not called urine because there are still things in here that we need. So this is where we reabsorb those things, kind of take them back. So we have good things in here like amino acids and glucose, extra water, and salt. So we are going to reabsorb about 85% of things of the amino acids and the glucose in here. And we're going to push everything else down here into the loop of Henle. So on the descending limb of the loop of Henle, there are lots of water channels called aquaporins, and it's going to push all the water out into the medulla of the kidney. And then when it goes to the ascending limb of the loop of Henle, those aquaporins are gone. They are replaced by salt channels or sodium chloride channels. So that's what's going to go out inside here. And this is important because the medulla has to maintain a very high salt water concentration in order for it to function properly. So that is how we maintain that high salt water concentration here inside the medulla. But as you can see, there's lots of capillaries in here because we're still doing some reabsorption in here. So we are reabsorbing things like sodium, calcium, potassium, and magnesium down here in the loop of Henle. Then everything goes back up to the distal convoluted tubule. And this is where secretion takes place. And secretion can be thought of as the opposite of reabsorption. So we're going to take back out of the capillaries, we're going to take back the things that we gave away, the things our body really doesn't need. Things like the hydrogen ion waste ions, the ammonia ions, the potassium ions. And then it's going to come back into the filtrate, and now it's considered urine. So from here, along with the urine from a lot of other nephrons, it's going to go into the collecting duct. And the collecting duct is going to send it to the renal pelvis, which then goes to the ureters, to the bladder, out the urethra, urethra and then excreted as urine. So that is how our nephron works. It's filtration, reabsorption, and secretion, and then finally excretion. Leave me questions, comments. I will do my best to answer them. Thanks for watching.